Welcome to another series of webinars from SAIEE. This is a series, it's going to be a monthly series of webinars from SAIEE sponsor, Rosatom. And before we start, let me just read the process. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located to the right-hand side of your screen. The chat function is reserved for the webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, they're encouraged to ask questions. A recording of this presentation made available on the SAIEE YouTube channel, SAIEE TV. The recording will also be made available on the SAIEE website under the Events drop-down menu in the section Past Events and Webinars. This page is updated regularly to ensure you check back as often as possible for new page updates, for new uploads, and subscribe to our YouTube channel for more uploads. A certificate of attendance will be issued a few weeks after this webinar, once we've received the CPD validation number for this webinar from EXA. Just to comment on questions, we've got a number of speakers, and we will take the questions at the end of the seminar covering all the topics. So please keep the questions coming, but I'm going to ask you, but we'll answer when we get to the end. Okay, thank you. Now, just quickly, who am I? I'm the host. I'm Dave Nicholls. I'm the chairman of the SAIEE Nuclear Chapter, and my photograph looks absolutely terrible there. I'm ex-Navy. I've been with ESCOM for some 34 years. So I retired from ESCOM about 18 months ago, and I'm now the chairman of Nexus. I'm also, more importantly, the chairperson of SAIEE Nuclear Chapter, which is the organization driving this process. This particular webinar is being driven under one of our study committees in the nuclear chapter, and that is the study committee on nuclear nexus for applications, and it works within the United Nations Sustainable Development Agenda 2030, transforming our world, and you can read the words, and we believe nuclear has a very important part to that. And the topics that are currently being looked at and the areas that this study committee is talking about: energy security, water security, electric vehicles, energy intensive heating and cooling, waste beneficiation, food security, and the Industrial Revolution 4.0 and big data, which has changed how we look at things. So that's very briefly what the overall topic is, and Rosatom's talks over the next few weeks, next few months are going to fall inside this criteria. So with that, I'm going to just pass you across to the chairman of the study committee, Pat Naidoo, Professor Pat Naidoo. Sorry, apologize, Pat. He's a chairperson of the NI this nuclear study committee. He's a professor of research in the Faculty of Engineering and Built Environment, University of Johannesburg. He's a fellow of the South African Academy of Engineers, a fellow of South African Institute of Electrical Engineers, and a senior member of IEEE and a member of IET and SIGRE. He's a registered professional engineer and a specialist consultant in electrical energy and power systems. His current research interests are sustainable development as driven by the green economy and Industrial Revolution 4.0. His 4-decade industrial career was with ESCOM, from engineering training to non-executive director, and I think he left before I did, about 2 years ago, and is now working with UJ. So with that, I'm going to pass you across to Pat, who will give you some words. Prof Naidoo, I can't hear you at the moment.
My apologies. Thank you, Chairman. Right, in all the work, sorry, we're going to focus on the nuclear nexus of applications, and we're going to use the United Nations agenda as our reference. Right, in all the work we do, we are going to look at how best can we strengthen the aspirations of the Sustainable Development Goals. And we're going to zoom in to the nexus of energy, water, waste, health, transport, and food. Sort of go into the intersection of the Venn diagram for each of these sectors. Now, the goals are defined. They've got key performance indicators, and we're gonna look today at goal number 6, clean water and sanitation. And we'll touch on goal number 7, goal number 13, etc. But again, zooming in on clean water and sanitation. Right. If we look at South Africa and where we are, looking at it from yesterday, today, and tomorrow, our belief is that we've got to sharpen the focus on unemployment, poverty, and inequality as our standing challenge. And we've got to zoom into this whole chapter of service delivery. How can we give to all our people a better quality of life? And I think that's the aim and the objective of our workings at the Institute, a better quality of life for all our people. And when we look at service delivery, we want to zoom into water, the water sector. And again, when we look at water, we find that our sole source of all the water that we use comes from rainfall. And this is water that we use as in daily living, as in economic activities, as in agricultural activities. It all comes from rainfall. Now, rainfall was okay for yesterday, but as we move into tomorrow, we find that there are too many variables surrounding rainfall, too many variables. And there's also too many variables surrounding the collection and the delivery of rainfall to the customers. And again, when you've got variables in an equation, it's very difficult to control the outcome. And we are saying, how best can we zoom in and help start managing the variables that are in our delivery of a better quality of life to all the customers? The question asks mathematically, how can we enhance SDG 6? Safe drinking water for all, better quality water, integrated water management, more local participation, international cooperation. And here we've got our colleagues from Rosatom that will share with us today their achievements in terms of contributing to SDG number 6. Let us reflect in terms of our reference and our workings. The sun is the sole source of all energy. And that's a fundamental given. Energy is neither created nor destroyed. And our best representation of the energy of the sun collectively is that of the periodic table of the elements. And industrial revolutions 1, 2, and 3 has shown how best we could use the carbon element in our daily activities. Oil, coal, gas, all from the carbon element. And they've given us economic activities that we can go on and create value added services and products to society. We're slowly migrating towards that of the hydrogen society. You hear a lot of talk around the hydrogen economy, electric cars, electric vehicles, and we leave that for another day. But let us also look at uranium. And uranium has been around for a long time, and uranium has given us lots of energy, high density energy. And we have Koeberg Nuclear Power Station outside Cape Town that delivers to us 100% electricity, 365 days a year. In fact, those Koeberg reactors work to almost on average 450 days non-stop, 24/7, 100% delivery. So we're saying to ourselves, how best can we look at the uranium element going forward in our discussions with respect to water security? This focus on uranium is along the following lines. It's a heat source. It's ideal, it's constant, it's predictable, it's controllable. zero environmental emissions. It's a clean source of secure energy. And I think if we can bring intelligence to bear on this element or this energy carrier of the sun, then I think we can make a great contribution to the entire agenda of water security. And may I take this opportunity of thanking my colleagues from the Water Research Commission and from Rosatom for joining us today and sharing the work that they are doing. Thank you very much, colleagues, and I'll hand you back to the chairman. Thank you, Chairman.
Okay, thank you very much, Pat. We're now going to pass across to Ryan Collier, who is the acting CEO of Rosatom South Africa. He joined them in October 2014 with the task of promoting Rosatom brand, as well as driving public awareness of nuclear in the region. He boasts a wealth of experience in tech communications. So with that, I'm going to pass across to Ryan to say a few words from the sponsor.
Thank you very much, Dave. Can everyone hear and see me?
It's across to you, Ryan, yes.
Perfect. I don't need to share my screen, so I'll just say a couple of words. Thank you again to the South African Institute of Electrical Engineers for this opportunity. We greatly value this opportunity that we have with you to discuss various challenges and solutions. Globally, clean water is becoming more and more of a precious commodity, and as populations grow and industrial and agricultural activities increase, so our access to clean water minimizes. This global issue is only exaggerated in South Africa, which is considered to be a water scarce country, and has an average rainfall of roughly 400 millimeters per year, which is almost half the global average, making South Africa the 30th driest country in the world. While it is estimated that close to 90% of South African households have access to piped water, most of these households don't have running water directly to their homes. The global COVID-19 pandemic has further highlighted the country's clean water shortages as people require better access to clean water for sanitary purposes. At Rosatom, we have a vast range of water treatment solutions, from desalination linked to large-scale nuclear power plants, to wastewater treatment, and all the way through to mobile water treatment units. You'll become acquainted with a broad range of these Rosatom technologies in the final presentation of this webinar. I must just apologize on behalf of my colleague and our technical expert, Andrey, who has become otherwise indisposed and is unable to join us on the webinar today. However, we have Alexandra online with us, and I'm reliably told that she is an absolute expert in the water field. So yeah, later we'll hand over to Alexandra. Dave, thank you very much, and I look forward to the rest of the webinar.
Thank you, Ryan. And I think it's a pity we haven't got what's it with us, but I'm looking forward to the presentation from them. I will now pass across to the first presentation, the first serious presentation, which is by Dr. Mandla Msibi. He's a Group Executive, Water Research Commission. He's an environmental pollution scientist with PhD in environmental chemistry from the University of Birmingham, UK, and then MBA from the University of Pretoria. He has over 24 years experience as a lecturer, researcher, research manager, knowledge manager, innovation technology and transfer executive, and is now the Group Executive, Innovation and Impact at the Water Research Commission. His experience includes research, project management, potable water treatment, head of information technology department, knowledge dissemination, and leading intellectual property protection and technology transfer office. He also worked for the Tshwane University of Technology as the Director of Research and Innovation, and later the University of Johannesburg as the Executive Director, Research and Postgraduate Studies. And with that, I'm going to pass you across to Dr. Mandla.
Thank you, colleagues, and I truly appreciate the opportunity, and I thank the South African Institute of Electrical Engineers for organizing this interaction, and also Rosatom the partner and also the University of Johannesburg. Chair, thank you very much. I'll start with my presentation and I'll put it on the screen and I hope it's visible. I'm going to talk around the emerging water innovation space. And the way I want to present this is I hope I will be able to reach out to people who may have considered themselves outside the water sector, because indeed the future we are looking at in terms of water supply in South Africa requires a range of skills to come together to come up with different solutions than the one we had in the past. I always say the approaches and the interventions we put together all these years were probably sufficient to take us to where we are today. But from here going into the future, we need a different set of interventions, and hence different skills, different professions must apply themselves and apply their minds into this water space. Because in any case, without water, nothing else really matters. Now, I want to start my presentation by showing this diagram. I think by showing this diagram. Each year around the middle of January, there is a report that comes, it's called the Global Risk Landscape. It's produced by the World Economic Forum. And that report gives us some insight, which I want to touch on because it does help us think around these issues that have given us great concern around water. So what they do in that report, amongst many other things, is to try to map the biggest risks that the world faces. I mean, this is a global risk landscape, and try to map that according to impact and also according to likelihood. And I'm interested in the top corner where you have the highest impact and the highest likelihood of these events actually occurring. And you can see there in that corner, if I go to my next slide, I've just expanded that particular corner. You can see in that corner, what we have predominantly is climate action failure, biodiversity loss, natural disasters, human-made environmental disasters, and extreme weather. And then, of course, we've got cyber attack, and then next to each, we've got the water crisis. Now, these, they are green, so they are natural things, they are environmental, so they are likely to happen without much human intervention. So we need to take note of that. Now, this next slide actually tries to see what has been happening for the past 4 years, including this particular year. So you can see that extreme weather, natural disasters, climate action failure, and biodiversity loss, they've been dominating the top 5 for the past 5 years. And that must be cause for concern, because all these ones, the ones that are marked in are colored green, they've got a direct impact on the available water for our countries or for our people, direct impact. And those that have got direct impact on available water, they are now dominating the top 5. If I go to my next slide, showing the South African map. In this slide, it's a bit old slide, it needs to be updated, but the information is generally not changed much, what is contained in the slide. So what is in that slide? We've got 2 blocks, one is blue and the other one green. The blue one shows the available water in that particular catchment. As you can see, there are catchment areas, they are colored in all together. I think we've got 19 catchment areas here in South Africa. So each catchment has been analyzed, and here we're showing the available water and the required water. So it's more like the water supply and water demand. The ideal situation, what we all hope for, is that the blue block must always be substantially higher than the green block. So if the green block is equal to the blue block or even higher, then we know that we have got a very concerning situation. And it happens in some of the catchment areas, like here in Mpumalanga, you can see it, this one as well, this one as well. And then you go to the Cape area, you can see what is actually happening. The water that is required is more than the water that is available. Now, that also, it's something that I just want to paint there in front of us and say, this is the situation that we have. And then we go to the next slide. It also shows the predominant pollutants spread around the country, where, for example, there's pollution around agricultural chemicals, by agricultural chemicals, pollution around groundwater. The black areas indicated in this map, this is where this pollution or the water quality is being affected by some of our activities as human beings. Generally, when you then take a global look at what we see in front of us, almost every water space in South Africa is affected by pollution. So now what I've covered is the challenge facing the water quantity in South Africa, now a challenge facing the water quality in South Africa. So, and then I want to go to this slide as well. On top of those two challenges, the water quality and the water quantity, we have got this issue that also Prof Pat touched on, that we've got these three challenges in this country: inequality, poverty, and unemployment. But there's something that I want to bring here as a role of R&D and the interventions that we can make out of R&D outputs. For example, we get knowledge solutions from R&D outputs, which we can use those to deal with poverty and growth in the country. We've got, we can use our R&D to transform there's a lot of transformation going on in terms of getting people who were not involved in the economy now involved in the economy, dealing with the challenge of inequality, and also out of R&D with new services and products developed, it may result with new enterprises and being established, and that will deal with unemployment and hence our competitiveness as a country. So what I'm saying, the challenges that we see both in the quantity of water, in the quality of water, should actually force us to do more in terms of generating solutions. As we generate those solutions, we will come up with products and services which will result with enterprise development and the transformation that we require as a country, and that can help address those challenges of inequality, poverty, and unemployment. In other words, in the middle of this, what I would call a crisis water situation of South Africa, something good can come out of it. Now, I also want to touch quickly on this particular slide because it talks to something that we're doing as a country in terms of the water space. When it comes to our R&D, in the past, there was a bigger focus on the academic impact of our research. That means contributing to the knowledge pool. And at the same time, a realization that it needs to inform policy and it needs to impact on policy, change policy and practice. But more and more, we are talking nowadays about socio-economic impact, that our activities, our research, our whatever we are doing, it must result with real benefits for the society, and it must result with economic development, because we've got these three challenges. And it's not only South Africa, actually, the rest of the world has got those three challenges. So that's how we're looking at our activities. We're more now interested in activities that will bring about socio-economic impact, without, of course, ignoring the academic impact, the conceptual impact, how it impacts on policy, and how it changes policy, without ignoring those. Now, I want to address this. Therefore, given that landscape that I've just painted, the quality, the quantity of water, and the national challenges. But within that, I've just created a space to say, in the light of these challenges, there are opportunities. And now we need to try and respond to this and see how we address them. So I've got this first paragraph there that says, water resources present a myriad of complex, interconnected problems which cannot be solved through one discipline alone. So my plea here is that a lot of different disciplines now need to come together. A lot of collaboration between academia, government, water sector, industry, and many other partnerships. We need to work together in this space. And the reason being that we don't have enough water and the quality is going down. So the future of water, or the future supply of water, will depend on the technologies and the innovations that will be rolling out from now on. So if we are rolling out new innovations and new technologies, obviously new skills are required to innovate. New skills are required to commercialize these technologies, and new partnerships are required to come together and to make this whole thing work. So the future we desire, I'm just emphasizing this point of skills, will require different skills, will require the existing skills and much more skills to be brought into the plate. Now, we learned from recent events in the country where we are having shortage of rain, and we're beginning to realize that big dams and big pipes, they are not really sufficient, because when there is no rain, then they're also not going to help in any way. But they've been extremely useful to secure our water from the past until today or in the near future. But one of the things that we need to be looking at is not only to provide more water, but how we use the water as a country. The behavior of water users, the wastage behavior must come to an end. And also, the other point that I want to make, the use of the word waste also has to come to an end when it comes to the water sector, because there is no water that should be called wastewater, because any water must be treated as a water source, a water resource, and be beneficiated to give us very good quality water. Now, I give this as an example to impress upon us, colleagues, that we do need urgent innovative solutions for tackling our water and climate change challenges, the ones that I've outlined in my first few slides. Now, I've also outlined the fact that if we do that, it will actually lead to economic development and job creation, because out of the innovative solutions, we'll get new enterprises and new industries emerging. And also, I've already emphasized the point of we need a new set of skills. We need a new set of players. We need a new set of professions. We need a lot of people to come into this space and to change the water management approach that we're currently using. I've used this diagram to capture some of these things, to say our behavior needs to change from a waste and inefficient use and practice into a water-wise use and management. And then our approach, remember what I've been talking about, the linear approach. You've got a water source, you use the water, and then it goes to waste. And in our thinking, that's sort of like the end of it. Instead, we need to be embracing innovative and complex ways of managing water, such that we have got nothing called wastewater. Any water can be repurposed, recycled, reused, and in the system. When we do that, we're then dealing with what we call the level of resource security. We will move as a country from a country that is water, energy, and food, that is at a water, energy, and food risk, into a country that is basically has got a high level of water security, high level of resource availability. That's what we want to see, and that's what the thinking and the talking and the engagement with our partners, that's what we're trying to push, that this is the way we should be working towards or working together. I sometimes use this particular diagram to illustrate that we have just come out of winter, for example, when we talk about behavior. And normally when people jump into the shower, they will open the water, clean water that will flow into waste while they're waiting for the hot water to come out. And that's wasteful behavior. But there are technologies which can help us avoid those things. So that actually begins to illustrate the role of innovation, the role of technology in water management. I also put these diagrams just to help us think around, to challenge us around these issues. I mean, if you look at our bath in the bathroom, it's a huge container of water that we fill it with water and we jump in to take a bath. But we could put a little bit of water and adjust the bath in terms of If you are washing your feet, the water is more on your feet. If you are washing your upper body, the water is more on your upper body, thus saving water. I like that briefcase because it caters for your sanitation as well as you travel. Now, there's also a lot of work that is happening around the sanitation. I mean, that is actually a very good example where all over the world, it's not just South Africa, we're using generally clean water to push waste, to transport waste. And that thinking, we're also working on ways to making sure that it changes. And again, it requires a lot of work, a lot of engagement to actually deliver to our society a toilet of the future. Because the one that we have now, I can place the same argument, it's not the one that will take us into the future, given our water situation in South Africa. I was chatting to somebody this morning and saying, you see, the toilet that we need is the one which will separate the liquid and the solids. And as you use it, it will analyze everything on a daily basis. Each time you use, it will collect data about your state of health, and it will share the data with your medical, with your doctor, and automatically you might even get an email that you have an appointment with your doctor because there is data. But when you do that, I'm looking at a bigger picture than that. Then you get the medical aids and other people interested in such a toilet of the future because it provides them with data that can monitor the health status of anyone in South Africa, and we're able to react, not only South Africa, even the rest of the world, to react and assist before there is disaster or there is a bigger concern. So even the toilet that we're using today was a good one to take us thus far, but we need certainly a different one for the future. Now, I was only trying to say here in this slide that when we talk about water, there are many sectors that are actually affected: agriculture, industry, mining, even sustainable human settlements. And these are some of the areas that bring together all these people to work together, or it makes us consider or work with these partners. The 4IR water management, the new sanitation, what I was talking about, that we need a new sanitation approach. The water energy food nexus, water sensitive design, water and wastewater treatment, or smart water, smart wastewater treatment, new water taps, supply diversification, water quality, and an environment. In fact, in reading what was presented as the approach for the South African Institute of Electrical Engineers, I was very excited because some of these matters are captured there already. So the partnership for me looks like it's in the making in any case. With that said, colleagues, thank you.
Thank you very much indeed, Dr. Msibi. I am just a second. Yes. Thank you indeed. I'm fascinated by the idea of a mobile bath. I'm not quite sure about the toilet in a suitcase, but I do think that the bath, the rocking bath, sounds interesting. Okay, thank you indeed. I said we'll take questions at the end, and we look forward to any questions. And thank you for the presentation of almost the issue statement of the problem statement. As we said earlier, Andrey Grinevich is unfortunately unavailable. I'm now going to pass across to Alexandra Kochinga, who is the project manager of Rosatom Smart Utilities, to explain, hopefully, some of the solutions that go with these, help South Africa sort these problems out. So across to you, Alexandra.
Yes, thank you. Just one moment to show my presentation.
Thank you.
Okay, I hope you can see it, the presentation.
Yes, thank you, it's clear.
Okay, I would like to thank all the previous speakers. It was very interesting and inspiring to listen to the reports, and I would like to introduce now myself. I'm Alexandra Kochinga, the manager of Rosatom projects basing on clean water. We work on communication and different projects abroad, mainly water projects. Now I would like to present our company. as well. Okay, the main company of us is Rosatom. Rosatom company is one of the hugest in Russia. It's State Atomic Energy Corporation. It includes more than 300 industry enterprises and has a lot of machine building enterprises in Russia and abroad. We are Rosatom Smart Utilities joint stock company, and we are part of Rosatom family. Now we have 5 thermal power plants all over Russia, and we are working on such projects as clean water, smart city concessions, and water, heat, and power supply. Our company is an industry integrator offering industry competences that include supporting a full cycle of production of equipment for water treatment, water purification, and desalination of saline waters. And everything is based on the decisions of Rosatom Corporation. Here you can see the current situations in water, actually. So we see that we feel now the lack of clean and potable water, and that brings us to the Sustainable Development Goals, number 6, the clean water and sanitation. Our aim is to provide that clean water and sanitation everywhere where it is needed. Okay. Here we roughly write the main problems in modern world in water. These are water consumption growth, clean water availability is quite low nowadays. The efficiency of use is also not at the high level, and that brings us also to the water loss problem and water pollution. Now I would like to present our main solutions for water desalination. We present atomic water desalination, that's a desalination plant integrated with nuclear power plant of high or low capacity, depending on the customer's demand, and also non-atomic desalination plants integrated with non-atomic generation, and also standalone desalination plants when there are no power plants near the desalination plant. I would also like to describe our experience. Here on that slide, you can see the main projects on water. You can see it's in Kazakhstan and in Russia. And also currently we are working on a project in Kazakhstan, another one. It's a desalination plant for 40,000 cubical meters per day. Today we are working on the project, on the construction and the operation of desalination plant in the Mangistau region of Kazakhstan. We will provide fresh water to general public as well as the industrial oil producing and agricultural infrastructure of the region. And currently we've created a company in Kazakhstan. We are developing the technical documentation, and we are now approving it by the state expertise. Okay, here you can see the main range of products and application. You can see that the range of applications is really wide. So basically any industry can use the desalinated water from our power plants. It's power industry, oil and gas industry, light and heavy industry, food industry and public utilities, also medicine and other industries. And I would like to show you the scheme of water desalination solution. It can be used for atomic and non-atomic power plants with high low capacity, also depending on the customer's demand. So it includes first treatment, the filtration one, then desalination and mineral saturation. Here are some facts about desalination solutions integrated with nuclear power plants. It can produce up to 7,100 desalinated water per cubic meters per hour. And it can be used by large industries and customers. I would like to point the safety aspects. These are ecological safety. The liquid radiation level is very low and it corresponds to all relevant safety standards. The next slide is also show the diagram of the desalination process. And here we also like to point out the economic, production, environmental benefits. The main are, of course, the environmental. And I can say that that atomic desalination is really environmental friendly. Here you can see the diagram of industrial wastewater treatment. And now advantages of modern technological scheme. As a conclusion, I can say that we provide all sorts of desalination. It can be it can be based on reverse osmosis or evaporation, and it can be based on different power plants, atomic or non-atomic, and we are ready to work on these issues. Thank you.
I was muted there. I'm now going to look for any questions, and I'm not at the moment seeing any questions come up, but I will ask a question of our Russian friend, Alexandra's. You're building a 4-unit nuclear plant in Egypt linked to a desalination plant. Could you just make comments on how big that will be in terms of production? Because that clearly is interesting for South Africa, because we're looking at the prospect of putting potentially more nuclear units on the Coburg site, which might well be linked to a desalination plant. So what sort of capacity in water per day are you running out of the,
yes, about the Kazakhstan desalination plant, because the Egyptian plant is now just on the stage of discussing. And the Kazakhstan desalination, yes.
Yeah, sorry. Okay, I'm now going to pass across to the moderator. I'm going to, is Prof Naidoo there?
Thank you, Chairman, I'm here.
As the moderator of this session, I must pass to you for the to manage the question session and the closure, please.
Thank you, Chairman. Thank you. I also note there's no questions posted on the questions box. So let me ask of the attendees, colleagues, if you have got any questions, possibly raise your hand and bring them forward now. And while that's coming, I've got a question also for not necessarily Rosatom, but probably for all of us. Currently, we have freshwater delivery to South Africa from rainfall. And again, we're looking at also supplementing local rainfall with cross-border water transfer. For example, in Gauteng, we bring all the water from Lesotho. And there's certainly a price to the fresh water that we bring from Lesotho. There's the price for sourcing the fresh water, and the price for transportation or the delivery of the fresh water from Lesotho to Gauteng. Have we got any feel for benchmark cost values in terms of water recovery? What are we looking at? Is it sort of a ratio of 1:2 or 1:10? I've got no feel for that. Could possibly anyone assist? Open question to anyone. Rosatom, in terms of your experiences, has there been any work on the cost ratios? Okay, all right, that's something we're going to have to...
Can you repeat the question, because I wasn't sure the last part of your question.
Yeah, sorry, Dr. Msibi. No, we bring fresh water in from Lesotho. There's a price to it, as in securing the fresh water from Lesotho, and then the transportation cost to bring it from Lesotho all the way to Gauteng. Now, and probably if we landed here at Gauteng, say at 2 units, say we buy it for 1 unit, we add 1 unit of transport cost, we then have 2 units of cost attached to that fresh water in Gauteng. Now, if we had to take wastewater and treat it and process it and make fresh water, what would be the cost thereof? Is it sort of 2 to 1, 10 to 1? See, that's a feel I don't have. We need to get a feel for that. Okay, that's fine. Okay. We'll do some homework on that.
No, but let me just add one point, Prof, because the movement, the transportation of water from the Lesotho Highlands to South Africa is done via canals, and most of them are gravity flow. So on an operational cost, they are very, very low, but obviously the capital costs were extremely high. And I believe even when you look at the treatment of wastewater to drinkable quality, the capital costs are quite high. But Prof, what I normally say, in a country that does not have enough water, what is a reasonable cost of water when you do not have?
No, agreed. Yeah, no, agreed. Yeah, I think we need to find that sort of integrated technical and economic solution. We need to find that.
Prof, I think just to highlight on that, we have a number of technologies within Rosatom for the treatment of wastewater, for the treatment of even acid mine drainage, and we could basically take that back to potable water. So the question actually is, how much are you paying currently to take municipal wastewater and clean it to a level that we put it back into our river systems, right? There's already a cost involved in that. So I do not see that taking it that extra step from being grey water that's allowed in our river systems back to a potable water that can go back to our system. And as the previous speaker said, that we really need to stop thinking about water as wastewater. We shouldn't have such a thing as wastewater. If we're going to be spending the money to actually treat the water to a point where it's good enough to go back into the environment, we may as well close that loop and send it back into the system to be reused.
Excellent. Thank you. No, that's very clear. That's very clear.
I heard someone once say that water in London has been through a recycling plant 7 times on average. Something insane. And I think that's an interesting number to think about.
Yes. Okay. No, there's certainly work for the study committee. Sorry.
Prof, sorry. Another thing that could seriously be considered is currently, especially in Gauteng, we have a number of mines that surround the entire city of Johannesburg, all of whom pump water out of shafts, and they either go into sort of special dams that hold them, or they need to be cleaned, right? And all of these mines contribute to their rehabilitation funds, and it's their responsibility really to take care of that water. So another question is, why are we not using that water that needs to be cleaned to go back into the environment anyway? Why are we not using that water and that money that is being set aside for mine rehabilitation to use that so-called wastewater as potable water at the end of the day? It needs to be cleaned. Again, we may as well take it a step further and use it in the city.
And bring that in back in, so you get the whole circular economics at work. No, agreed. Now these are all the ideas for the study committee to work upon and to come forward with proposed desktop solutions, and we could then take it further.
That would be fantastic, and we would actually love to play a role in that. So please feel free to contact us in terms of the technology, in terms of what's available, and we can look at what it would cost as well. And I think that would be a fantastic study to have, Prof.
No, excellent. No, thank you, Ryan, for that, and we'll certainly build upon that. While I've got you on the line there, the desalination solution integrated with the nuclear power station, and yeah, I'm going back to our Koeberg facility down in the Cape. As you know, we bring in the seawater, and Dave can give us the numbers. I think it's about 40,000 liters per second per reactor. So there's quite a bit of water that comes in to cool the reactor. And then we sort of lift the temperature up a few degrees and send it back into the ocean. And I've noted in your presentation the integrated solution to manufacture fresh water. Possibly, could you comment on whether we could do a brownfield retrofit to Koeberg?
Honestly, Prof, I'm not a technical person, but that is something that we could certainly look into. Obviously, it would make more economic sense to add it to new units. So, for instance, there's an RFI out at the moment for new nuclear in South Africa, and it specifies big block and it specifies SMRs. And under the big block, they're looking at large-scale desalination. So I think, I mean, in my mind, you've got a city like Cape Town that's currently relying on Koeberg for electricity, who has a desperate need for water. And I mean, it was just a couple years ago where they were actually looking at a day zero scenario with no water, which is unheard of. So to build 2 new units at the Koeberg site, where you've already got existing infrastructure and it's a brownfield essentially, building two new units and 2 large desalination facilities there makes absolute sense for the city of Cape Town. And I'm happy to share more information on the size of that. It obviously depends on the size of the reactor that they go for, whether it's 1,000, 1,200 megawatts. But if I'm not mistaken, it's roughly around 170,000 cubic meters of water per day that could come from each unit. Don't quote me on that, but I will definitely share the information with you for your study going further.
Oh, thank you, Ryan. Thank you, Dave. You want to make any comments there?
On desalination, I think Cape Town is the obvious answer in Cape Town. I know we're looking at doing this. We were discussing options with Koeberg, but it's quite limited what you can do, given you aren't linked into the steam system of the plant. But I think the Egyptian model is what we're clearly looking at as a reference point.
Right.
I'm going to suggest. I mean, I think the water team has to get together with is, and I'm a great believer in doing this, is to find out what is the break-even cost, both of the customer and the technology. In other words, at what price per cubic meter would Brand Water say that's a reasonable price? We can see that being sensible. And is that a price at which some technology can generate clean water?
Right.
Because often we get discussions going on where we talk about technology, but the question is how much effort's involved. Now, money is a marker for energy, for my kind of work required. So I think we've got to look at that discussion and try and be aggressive in terms of what we do, because clearly we have a problem in South Africa. It's not going to get any better in the next decades going forward. And what actually worries me, and it worried me in the Cape Town situation, was that when they had the day zero time everyone was talking about major projects, which have like an eight-year lead time. As soon as day zero went away because it rained, everyone seems to have forgotten about the long-term projects. But by definition, the lack of water happens faster than the building of the project sometimes.
No, agreed. Yeah, that's a valid point. Yeah.
Dave, I think I'd actually like to add to that, if you don't mind. We had a discussion earlier this year in Cape Town, actually. I think it was at African Energy in Durban. And one of the major issues with water is currently got a set tariff, you know, sort of across the board in the country in terms of residential use of water. So for instance, if Cape Town were to have desalination, how do you integrate that into the cost of water in Cape Town alone? Or is it spread across the country in terms of how that works? And another question is, could you own a private desalination plant and actually sell water through some sort of purchase agreement? And I think these are all scenarios that we really need to explore and put our heads around how to overcome. We're going to need new water infrastructure in the country anyway, and certain things are going to cost more than our traditional methods. So really, we need to understand how we either subsidize that cost or how it needs to go to the end consumer.
Yeah, no, agreed.
Yeah, can I also make a note? I really appreciate the questions that are coming up and the comments. But I would also want us not to limit in terms of limit ourselves in comparing the cost of supplying new water from non-conventional sources to the cost of supplying water from conventional sources, because this is where I think in our thinking we get stuck. We do that comparison, but as I've raised the point before, how much are we prepared to pay for water when there is no conventional supply of water? How much will a municipality, how much will the government, how much will an individual be prepared to pay for water when there's the normal sources of water are dry? Because that to me has limited our investment in coming up with new ways of delivering water, because we stop and then we say, if I go ahead with this innovation, it looks like it will produce water at a higher cost than the conventional supply. But that innovation may be introducing new water to the environment, water that would otherwise not have been available. So somehow we also have to allow that particular space. I agree with the comparison because we work with economists and they will tell us all sort of things. But also in designing future solutions, we also have to be aware that we might be dealing with situations where the normal, the ordinary, the conventional water is not available.
Okay, we've actually got some questions. I'm going to suggest that we go through a couple of the questions because they're now.
Yeah, I've got
I'm going to start with, I've got them here. I'll go through them from here.
Okay, got it.
And the first one's fascinating because I'm going to pass it across to Rosatom, but Cape Town needs about 500 megalitres a day. What size, in terms of power plant, would be required to provide that from desalination? And if I heard you correctly, Ryan, you were saying that the single unit 1200 megawatt machines were doing about 170 megalitres a day. Is that the number you were quoting?
That's correct. Yeah, roughly around there.
So essentially, about if you wanted to have all Cape Town's water coming from desalination from the Coburg site, you would need three
units.
More units like Coburg.
Yes.
3 reactors.
3 reactors.
And so that's an inch.
I think we can't discount that the fact that Cape Town already has water resources to a certain extent. So even adding an extra 170,000 cubic meters of water per day would certainly ease the burden on the conventional source.
Yes. Yes.
Yeah,
Be
I
the
suspect
balancer.
that as the current government's 2,500 megawatts would imply potentially, if we took the Coburg route, 2 more machines down there, that would actually be, if that was linked to the same deal as the Egyptian technology or the technology Rosatom's installing in Egypt, that would imply 340 megalitres a day coming out of the Coburg site, which I suspect will be very nice to have in 2032 for the Cape Town Council.
Certainly.
Okay, I'm going to the next one. Since water desalination is not dependent on dispatchable power, would solar or wind power not be more practical or economical for South Africa?
Who's that addressed to, Dave? To us?
I don't know. My answer, yeah, it depends how you desalinate, but I'd ask the question of try to view. You're the principal select talkers today, Ryan. So back to you.
Sure. I think so. In order to produce a large amount of water, you need a large amount of energy. So small desalination units, fine. You can, you're going to say 1 ton of water per hour. I'd easily run it off solar during the day. But where the nuclear desalination comes in very efficient is that it's huge amounts of water that are produced from excess heat from the power plant. So at the same time you are actually producing electricity, you're producing water, and that's where I think it really differentiates it. Sure, you do maybe you lose some of the capacity because you cooking the water slightly more, but that's really where the difference comes is that you're getting both electricity and water out of the nuclear plants, and you're basically just using the excess steam that would have essentially heated the ocean water slightly. So I think that's really the difference. And you're welcome to add on to that, Dave.
I'm on the same page. I'm going to try and move to the questions, but I asked this question. I think goes to Dr. Msibi because it's more about leaks are prevalent in municipalities. How are we going to highlight this and stem the losses as a focal point? Dr. Msibi?
Yeah.
Look,
water loss. Water loss.
Yes, we have to. Hello? Yes, we have to address the problem of leaks. We're losing more than 30% of our treated high quality water through the leaks in the country. And it's a huge amount of money. Obviously, as I was saying in the presentation, new technologies and new way of doing things will help us in detecting the leaks, prevention of the leaks, and dealing with the leaks when they actually occur. This is a huge area for the group to actually consider. What technologies can be rolled out, can be developed in order to deal with the water losses in our systems. It's a lot of loss, actually.
Okay, the next one's, what's the panel's take on maintenance? Most wastewater treatment works are in a dire condition resulting in severe pollution. How can better or cleaner service delivery be provided? Local governments are out of pocket and cannot maintain their infrastructure without grant funding. So that's a very general question to the panel. Pat?
Ryan was coming in. Ryan, are you there?
Yes, I don't want to comment on the current situation in terms of maintenance, but I do know that a lot of facilities are in dire states at this point. And I think that one thing that could seriously be considered and maybe explored is the fact that we could privatize a lot of these facilities and therefore take the capital expenditure goes on terms of the private company who funds it. And then you have an agreement between them and a municipality to either produce or provide clean water as well as take municipal waste. So I think there's ways around, simply giving grants and hoping that municipalities will run their facilities very well. There's obviously some legislation and various things that need to change, but I do think that the private sector has a very big role to play in how we solve a lot of these issues.
Concur, fully concur. Yeah, and I think if we bring in what we term the circular economics, we can give value to the waste and return it back to value. So that will work. That will work. And again, you're right, we got to get the policy people to come forward. Carry on, Dave.
Yeah, I'm going to move down the question list now. And again, I think is largely a question for Dr. Msibi. What is the current trend in monitoring pollution on the available water sources? Is there a mechanism in place to track the health impact of a person consuming contaminated water?
Yes, there is. We actually do a lot of studies on water quality, and also a lot of studies looking at emerging pollutants, and looking together with our international partners in terms of the effects of such pollutants on the life of human beings. So we do continuous studies in that particular area. Now, when you look at the general quality of water in those municipalities that are doing well, if I can use that term, the quality is reasonable, it's very good. But yes, there are challenges here and there caused by, as has been mentioned, poor infrastructure and lack of proper skills to actually manage, whereby you even find sewage water leaking into areas where it shouldn't be leaking into. So we are fully, I think we've got sufficient knowledge in terms of what are the impacts and the health effects of some or most of the pollutants. The ones that are challenging is actually the emerging pollutants, where we're still in the process of characterizing them as they come in now and again. But generally, we've had lots of studies looking at the impacts of such pollutants. And the only thing that is challenging us is to how do we make sure they don't really pollute our water, we don't get them into our drinking water. But we also know how not to get them into, how to prevent them getting to our drinking water. It's just a case of the infrastructure and the skills that is actually the bigger challenge.
Okay. I think we've covered all the questions that I can see on the screen, and I'm not going to promise.
No, got one more here from Pascal.
Okay.
Gauteng requires a lot of water and cannot continuously depend on the Vaal River for extracting and treating fresh water. They need to look into wastewater. How can Rand Water, as the bulk water utility for Gauteng, play a role in wastewater reuse? There's a question from Pascal Motsalesi. Yeah, correct, Pascal. I concur with you. Rand Water's got to diversify its source of water, and there's definitely space for Rand Water to play in the wastewater portfolio. In fact, if we look at Joburg Water, which is one of your key offtake customers, they are called Joburg Water and Sanitation, so they play in both spaces. And I think Rand Water's got to come and also play in both spaces, water and sanitation. So there's definitely opportunity to look into that and again, from a business model point of view. I want to go back to Jeff's point on the application of renewable energy in providing water security. And I want us to reflect a little bit on the old windmill technology. And you see it out in the Free State, out in the countryside. Lots of windmills still work, and they bring up groundwater. And I think that's something we got to apply more and more. How can we tap into the old windmill type technology to bring up groundwater and apply it as in individual applications? And I think renewable energy, both solar and wind, you'd find a lot of the conversations are in the sort of micro space, the micro grid space, the smart grid space, you know, where the volumes are manageable. I think when you look at nuclear, and Ryan answered it correctly, it's just the energy density is so high, you could do both at the same time. You make electrons and you could use the waste or heat for water. So I think we need to look at scale here. How best can renewable energy at scale level be applied in the water security context? Similarly, for nuclear, how could we apply nuclear energy in the water context? So there's definitely work to be done in that space, Jeff. Those are my comments. Would you like to say anything from your side? I don't think Jeff would be able to speak. He's muted.
No, he can't speak. He
can't speak. Yeah. Sorry, Jeff. We'll pick you up in that conversation and under the study committee. Dr. Msibi, you want to say anything on renewable energy and its application to water security?
No, I wouldn't want to add anything there, but it's a subject matter I think the study group must look into, because I know that some of the technologies could not be considered in the past for water treatment, for water management, cost of energy. They thought they consumed a lot of energy, but I believe that with proper studies and an approach of looking alternatives, those challenges could be overcome. So it's a really more study area. Yeah.
Yes, certainly. No, thank you very much. Chairman, I think we've exhausted the list of questions, and there's good discussion. Can I give it back to you? Thank you.
Certainly. So with that, I would like to thank everyone for joining us. Thank you for attending the SAIEE technical talk today. Please visit the SAIEE website on www.saiee.org.za. Upcoming webinars. With that, I call for this meeting to be over. Thank you all very much. Enjoy Heritage Day tomorrow. Thank you.
Thank you, Dave.
Thank you so much.